maybe. There we go. Okay, so today we're going to focus a bit on graphing sine and cosine, taking a look at equations, pulling things from those, and then putting it into a graph. We will draw some graphs by hand, but a lot of times you'll be able to rely on things like Desmos or like for your homework, the IXL section. You'll see how graphing there works. So we'll take a look at that and kind of talk about how that's going to go. But for now, there's a helicopter flying over. It's a fun sound. Huh. Anyway, sorry about that. Got a little helicopter-y in here, noise-wise. Starting off with 4.4, part 3, graphing. Sine and cosine. So we actually do get to the graphing of things today. And when you're graphing sine and cosine, when you're drawing the graph by hand, it's actually kind of nice because you can scale the graph a lot easier in whichever way you would like to scale it. If you're drawing the graph on something that's already drawn for you, like if the scale is already chosen and whatnot, that can get a little bit annoying trying to figure out where to place approximate points if it's not scaled the way that you would have scaled it. But anyway, first we'll just graph a regular sine function. Okay, so in a regular sine function, when we're going to graph it, the first thing that I would do is start listing things like the amplitude, the period, vertical shift, phase shift, if there are any of those elements. So let's see. In the regular sine function, the amplitude is 1. The period is 2 pi. No vertical shift or phase shift. So if that's the case, from there, it's just kind of knowing what a sine function looks like. And from there, you can kind of use the unit circle to some extent because we know that sine represents the y values along the unit circle. And so the important ones are going to be things like pi and 2 pi and 0. So we'll start there, 0, pi, 2 pi. So we're going to graph at least one cycle of each of these. Actually, we'll graph 2 cycles. Let's continue this thing on. Okay, so you're going to need at least the halfway point within a period, and then you're also probably going to want the halfway in between those labeled. Like pi over 2, 3 pi over 4. Or sorry, 3 pi over 2. Gosh. And then 2 pi. And you can kind of stick the halfway points between those in there and have the scale of the graph imply it. You don't really have to label each individual one, but you can. And from there, we know that sine of 0 is 0. We know that the sine function in general starts at 0 if it's not shifted horizontally anywhere. We also know that it hits 0 again at pi and at 2 pi. And then halfway between the places where it hits 0, it hits a peak and a trough. So since the amplitude is 1 and it's not vertically shifted at all, we're going to label the 1 and -1 as the top and bottom. So halfway between 0 and pi, since sine starts by going up, it's going to hit the peak. Halfway between pi and 2 pi, it's going to hit the trough, or its minimum point. And then from there, we just draw smooth curves in between. And that's one cycle of sine. And you can continue that same pattern since it is cyclical. It's just going to continue repeating like that forever. Okay, so that's a standard sine curve and how we would graph that. From here, we're going to go ahead and graph a couple more things by hand. We're also going to take a look at what it looks like to graph things in Desmos and or on a TI calculator, just because those are also helpful tools that we have. So the second one we'll do, we're going to do f of x equals, we'll go 4 sine of 4x. So here we're changing the amplitude and the period a bit, but we still have no vertical shift or phase shift. Okay, so 4 sine of 4 theta, that tells us that our amplitude is going to be 4 because of the coefficient here. And then sine of 4x tells us that we're going to be changing the period a bit. So period is 2 pi over b, and in this case, b is 4. So 2 pi over 4, which is pi over 2. So now, instead of going through a complete cycle in 2 pi, it's going to go through a complete cycle in pi over 2. So the way that we scale this is going to look a little bit different. Okay. So first of all, we know that we're going to need to be going between 4 and negative 4. And then we know, since the period is pi over 2, and it's got to complete a whole cycle in pi over 2, then at pi over 4, since that's halfway between 0 and pi over 2, that's the other place where it's going to hit the midline, 0. And then halfway between each of those, it's going to hit the peak and the trough. So now we get to start labeling some points. So at 0, pi over 4, and pi over 2, we know it's going to hit the midline. At pi over 8, halfway in between, it's going to be up at 4. And then halfway between pi over 4 and pi over 2, it's going to be down at negative 4. So from there, so we can see that this one is a lot taller and skinnier of a graph. And we can do this again and make another cycle of it. So by the time we get to pi, it's going to have gone through 2 cycles. And when you're drawing graphs by hand, we're really kind of approximating here where things go. And so if the graph doesn't look perfect, that's okay. My graph sure doesn't look perfect. But most of what we graph is going to be graphed on a computer anyway. Okay. Any questions so far with just looking at those first two graphs and how we drew those? How did we get pi over 2 from 4? Good question. Um, so we know from the equation and from yesterday that the period is 2 pi over b, right? And so since b is 4, a is also 4, so that's probably a little bit confusing. But since b is 4, 2 pi over 4 reduces to pi over 2. And then pi over 4 um, is halfway between. So just like when we drew the first one, the standard period was 2 pi, and pi is halfway between 0 and 2 pi, and that's where it hits the midline again. Same thing happens here. At from 0 to pi over 2, pi over 4 is halfway between those, so that's where it's going to hit the midline again. So kind of when you set up your cycles, especially if it's starting at 0 and doesn't have a phase shift, you can kind of go in increments of half the period, and that'll kind of help to put it in the right, or I guess help you to be able to graph it a little easier. So Desmos will do some of the points for you, or actually it'll do most of the points for you. It'll hit the important ones, like the peaks. You'll be able to click on those, and also you'll be able to click on the points where it crosses the midline if the midline is 0. If the midline's not 0, then you'll want to graph the midline, and then you'll be able to click on the points where it crosses the midline. Yeah. So for the next one, let's take a look at what it looks like to graph it by hand and in Desmos. So, come on, stay. 3. Okay, so for this one, we're going to do f of x equals 3 cosine of 2 theta plus 3. Or not theta, x, because I used x here. Anyway, that's what we're going to try next. Because it's got a bit of a different period, different amplitude. It's got a vertical shift. So we're kind of adding another thing onto this. So if we were going to graph this by hand, and what I encourage you to do anyway, because it's good practice, is to write down the amplitude. Well, the amplitude is A, and A is 3. What's my vertical shift here? Three. Yeah, that's from what's added onto the n here. And then we want to find the period. What's the period going to be? If period's 2 pi over b, what's period going to be? Yeah, just pi. Okay, so we've got that information. If I was going to graph this by hand, well, first we'd set up the coordinates. But notice on this one that we're vertically shifted up 3. So the way that I draw my coordinate is not probably going to be centered at 0 like those ones up above were. I'm going to make this line a little bit lower. And we know that if our vertical shift is 3, that's where our midline is going to be located. So if you're drawing something that has a midline that's not the x-axis, that's the first thing I would do is go up 3 and draw a midline on the graph. Okay. And then we know that the period is pi, so the way that I'll scale on the x-axis is we need at least that this is pi, 2 pi, 3 pi, and then I need to go halfway between on each of those. So those are going to be the places where it hits the midline. And then halfway between each of those are going to be where it hits maxima and minima. So now that we know that since this is the midline and our zeros are where it hits the midline are going to be at 0, pi over 2, and pi because the period is pi and it hits the midline halfway through the cycle. So those are going to be all the places where it hits that midline. Then, since it's, oops, sorry guys, this is a cosine function. Goodness. Cosine functions start at the top. Sorry about that. I didn't notice that we had made this a cosine one. Actually, instead we'll make this sine and then we'll graph cosine afterwards. Sorry about that. We're going to change that into sine, since we're kind of already on that theme. Okay, so sine starts out going up from the midline, hits a peak, comes back down, crosses the midline. And since the amplitude is 3, it's going to go between 6 and 0, since our midline is also 3. So it's going to come down, hit the x-axis, come back up to the midline, come back up to 6, back down to the midline, down to the x-axis, up to the midline, up to 6. And it's going to continue oscillating like that. And typically your graph will look a little bit better than that if you graph it in an actual graphing calculator, which is what we're going to look at next. And we're going to do it with this exact function here. So, come on, internet. Go ahead and open up a window of Desmos. And the first thing that you do when you get to Desmos, we're going to hit the wrench. And we're going to look at a bit of changing the scaling and all of that on the axis. That's going to make our lives a little bit easier. The reason that it still is kind of nice to figure out the period, at least, of the function before you graph it on the graphing calculator is that it makes it a little bit easier to know what to scale it by. Because if your period is like pi over 3 or 2 pi over 3, then you're probably going to want your step size to be somewhere in the realm of pi over 3 or pi over 6. But if your period is pi, then you're probably going to want to scale it by pi over 2 or pi over 4. So the x-axis, we're going to go from negative 2 pi to positive 2 pi, just as kind of a standard starting place. From there, you can change how you would like it to scale and stuff like that. But this is generally a good starting location, negative 2 pi to positive 2 pi. You can also change how the y-axis scales based on your vertical shift and your amplitude and stuff like that. So like for this one, we probably would want the y-axis to go at least to like -1 maybe, and then at least up to 6 or 7. I'm going to go with 8 just to be safe. And then I'm going to scale it by pi over 2 on the x. And then on y, it doesn't really, the scaling doesn't matter quite as much. Okay. And then we're going to type our function. And I'm going to make this a little bit bigger. So it was 3 sine 2x plus 3. And that does look like about what we drew. So that's a good indicator that we did something right. And so these are the points that it naturally gives you. It gives you the maxes and mins, but it doesn't give you where it hits the midline unless you graph the midline. How do you get pi? You just type the letters pi. So like if I was doing pi over 2, you just type pi divided by 2. Is that what you meant? Okay, cool. So what I would do in this situation, if I was looking to then transfer this graph to somewhere by hand, what I would probably do is graph the midline y equals 3. So that then you get all of these points along the way where it crosses the midline and stuff like that. And then you can call all those points out and transfer them to a graph if you need to graph it on paper. Or if you're doing like an IXL assignment or something like that, you can pretty easily transfer this graph over to there. So yeah, once you start graphing these in a graphing calculator, the whole process becomes a lot easier. Any questions up to this point on the use of the graphing calculator, on how we would graph these things? Okay. So let's try doing it with cosine this time instead. We're going to graph 3 cosine of 2x plus 3. We see how it looks a little bit different, right? So if we were going to transfer this graph to paper, not 43, 3. I would also graph that line. Probably grab some of these points along the way. And this can also show you how you might want to scale your graph if you were drawing it on paper. So let's transfer this one to paper. And then we'll take a look at what these are going to look like in IXL. So this becomes a lot easier once you graph it on a calculator and then can transfer it to paper. I would probably scale this the same way I scaled the last one. We have 0, pi, halfway between those is pi over 2. I'd want the midline on there at 3. I'd want to go up to at least 6. From there, getting that midline drawn. You can graph the midline as a solid line, or you can graph it as a dotted line. Either way, when I'm drawing a graph like that, I find it's helpful to at least have the midline on there in some fashion. And then we remember that cosine starts up at the top. And now the garbage truck is here. So we've had a helicopter and a garbage truck now today. Good stuff. All right, so we start up at the top at 6, and then halfway through between 0 and pi over 2, we come down and hit the midline. Then at pi over 2 is where we come down to the x-axis. So at each of these points along the way, so for cosine, where sine was down at the midline for each of these main ones, for cosine, it's going to be either at the top or at the bottom for each of those main ones. And then at each of these halfway points, it's going to be at the midline. And if you're not careful, it can start looking kind of like V's going up and down while you're drawing. But anyway, so we can see it's a lot simpler if you end up just using a graphing calculator or something like that to grab your graph from. But if you were to not have a graphing calculator present, those first couple are how we would start the graphing process and stuff like that. But now everyone's kind of got a graphing calculator in their pocket if you want to download an app for it. But anyway, you can also, for those of you who have TI calculators, you can do kind of a very similar process using that. So if you would like to, I'll show you guys real quick how you would do it on one of those. All right, so the first thing I would do, graphing on a TI, you would go to y equals, and you would type in your function. So 3 cosine 2x, and the variable button, for those of you who haven't used that before, hopefully you have at this point, but there's the variable button, xt theta n. Since our calculator is just in the regular function mode, it'll use x as your variable. And then close the parentheses, plus 3. On your window, you might want to reset a few things. Like I have mine going from negative 2 pi to positive 2 pi, scaling by pi over 2. You might want to scale this one by pi over 4. So you would go second pi divided by 4. And then you want to change your y minimum and maximum. So I might go from, just like we did in Desmos, -1 to 8 or something like that. And then you can hit graph. The other thing I might do is, just like in Desmos, it doesn't show the midline and where it crosses the midline naturally. So I might, in y equals, also graph y equals 3. Add that to my graph. And then if you hit trace, you can jump around a little bit on the function, but it doesn't naturally tell you where they cross. So if you want to find where they cross on a TI calculator, it's going to take a little bit more work. So you're going to have to hit second calc, and then you want to go down to intersect. And so the first curve, you would pick the blue one. Second curve, you would pick the red one, or whatever color it happens to be for you. And then you can just hit enter again, typically, or you can move the cursor over to about where you think they cross and hit enter. And there it will tell you where they intersect. Notice though, on a TI like this, it doesn't tell you like in terms of pi over 2 or pi over 4 or whatever, where exactly they intersect. It gives you a decimal approximation. So if you would like to know the exact value of where they cross, then you're probably going to need to either use Desmos, or you can, like if you think that that's probably pi over 4, you can hit second quit and then see what the value of pi over 4 is and go, oh, that's the same value. So there's kind of ways around it in that regard, but I haven't found a way yet to have it give you exact values or anything like that. Anyway, so that's how we work with the graphing calculator for using like a TI calculator, which is all you're going to be allowed to use in like AP Calculus. So if you're taking AP Calculus, you might want to start getting familiar with something like a TI-84 or other graphing calculator. Anyway, any questions so far before we move on? Anything we want to see again? Okay, so now we're going to shift gears a little bit and move to the IXL and taking a look at that. And then we're also going to look at the Desmos activity. So I'm going to post both of those real quick. Okay, so we're going to jump back to Google Classroom. You might have to refresh the page. We have two things going on here. The first one we're going to click on is the IXL because the IXL has more to do with graphing. Okay, so the first thing says graph the function f of x equals sine of x. So this is graphing sine and cosine functions, so make sure you pay attention to which one it gives you. Since it's a sine function, we're going to click on this one that corresponds with sine. And right away, it just gives you the regular sine function with a period of 2 pi and an amplitude of 1. But if you wanted to change it, you can drag these points to change the amplitude. Oops, nope, come on. To change the period, you have to drag it the first point closer. So if I wanted the period to be pi over 2, I would have to set it here so that it goes through one whole cycle in pi over 2. If I wanted the period to instead be something larger, you'd have to drag it out this way. But usually it will scale it for you a little bit better if they want you to have a different period. So anyway, that's how we would start with just sine of x. Negative sine of x, you do the same thing, you grab that, but this time, remember negative sign makes it, instead of starting by going up, makes it start by going down. So it just reflects it over the x-axis. Or 2 cosine of x, so this time we would grab cosine, and then we would drag the amplitude up so that it's 2. Okay, so that's a lot of what our graphing is going to look like today. A little bit, or it's going to start out pretty simple like that, where you're just changing one thing, like changing the amplitude or things like that. If you want to change where the midline is located, you can grab this point that's on the midline and move it. So if I wanted the midline to be 2 instead, if there was a vertical shift, I would just move that up to 2. And a lot of this we can learn and do just by kind of clicking around and how we would, use that. It changes it symmetrically, which is nice. You don't have to go and grab all the points and change them. But anyway, so there's that part of the assignment. The other part of the assignment is going to be a Desmos activity. So if you click on the Desmos activity, you'll enter your name. And most of this activity is matching. So it's going to have graphs and equations, and you're going to match them with each other by clicking and dragging. So for example, regular cosine, that's going to be this one. So I would match those together. And you can kind of move things around so that you can see them a little bit better. Or 2 cosine, so I know I'm looking, or negative 2 cosine, so I know I'm looking for a cosine curve that starts down at negative 2 and isn't shifted. So that'll be this one. Or for 4 sine of x, I know I'm looking for a sine function with an amplitude of 4 that's not vertically shifted anywhere. So we're matching and going through and finding those. So each screen that you go through, you notice this one says we're just looking at vertical shift and amplitude changes. So we shouldn't have to think at all about phase shift or different periods or anything like that for this one. And then you get a question about what A changes and what D changes and stuff like that out of our function. And then on the next one, you look at changing the period, horizontal stretch and shrink, what happens there. And you match each equation to its graph. Okay, and there are 7 total slides. So then there'll be another question, another matching set where we work on phase shift, another question, and then one where we bring them all together and match the functions to their graphs. And that's the last one. Okay. Any questions in general about the assignments? Any particular types of questions that we want to go back to and talk about more? Okay. If you do have questions, please stick around. Otherwise, you guys are free to go and work on your own. And have a good rest of your day.